This video is for Chapter 2, Section 1, Linear Equations in two variables. If you guys would all please open your textbooks to page 160, we'll get started with this. So a lot of this stuff I think you guys are going to find quite familiar, so you should like that for a change. Linear equations in one variable. One of the models that we tend to look at as a very common way to represent these is the y equals mx plus b model. Recall that m, or the coefficient in front of x, is going to be the slope of your line, and b, or the constant at the back, is the y-intercept. When we talk about slopes, we have essentially four varieties that slopes can come in. You can have a positive slope, whereas x increases, y increases as well. You can have a negative slope, where when x increases, y decreases. Slope of 0, that's where you'll have no rise whatsoever. And then undefined slope is where you have no run whatsoever. Now the reason that one ends up being called undefined, if you remember your rise over run ratio for slope, the run is the bottom of that ratio. And as in our last chapter we talked about having zero in denominators of ratios or fractions, that turns into an undefined amount. So if we were going to sketch one of these, so quick review from the past, b, or our y-intercept in this particular equation, is 2, and then our slope is negative 3, or negative 3 over 1. So we begin by graphing our y-intercept, then use your slope to count that rise and runoff to come up with another point on your line. So down 3, right 1. Also remember or consider that a negative 3 could be recorded as positive 3 over negative 1, which would have sent us up 3 and left 1. Notice though that no matter which one you go with, you are going to come up with a graph of the same line. Like so. Now this graph, y is equal to negative 3. When we have an equation of a line with one variable, that should trigger a memory that you're either going to be ending up with a horizontal line or a vertical line out of that. So what I suggest doing is give yourself a fast, easy value where y is equal to negative 3. Right down here on the y-axis. Okay, y is definitely negative 3 at that point. Now, where else would there be a y equal to negative 3 value? Now, if you would accidentally run vertically from that first point up to, say, a negative 2, y is not a negative 3 anymore. It's a negative 2. So you've gone the wrong direction. Maybe that'll help us all make sure that we don't end up with a vertical when we should have a horizontal line. This is a graph of y equals negative 3. How about if we got one like this, where the equation is technically in standard form rather than y-intercept form? You simply have to rearrange it. So move the 4x to the other side of the equation, and now you have it. So we would graph our y-intercept at 5, and there's your slope of negative 4 over 1. And there's the graph of the line. Now, finding a slope of a line, if you've been given 2 points on a line, remember this formula from the past. Slope is equal to y2 minus y1 over x2 minus x1. Now, you can consider either of the two they give you as x1, y1, and the other one is just going to be the x2, y2. All right, so it does not matter the order in which you load those points. But I will caution you, if you treat one point as x1, the partner to that has to be y1. All right, so you can't mix and match the x and y coordinates of two different points. Let's take a look. if we were to find the slope between these first two coordinates, okay, if I call this point x2, y2, and this one x1, y1, I would end up with 8 minus a negative 6 over 2 minus a negative 5. So 8 plus 6 on top, 2 plus 5 on the bottom, which is 14 over 7, or 2. So 2 would be the slope of the line containing those 2 points. Let's do the same thing again for B. If I have, again, this one is x2, y2, that would make this one x1, y1. So y2 minus y1 over x2 minus x sub 1. And I end up with negative 1 plus 1 on the top, which is 0. So with that slope of 0, I know that I would be looking at a horizontal line. Another way of writing linear equations is point-slope form. Again, this is something that you've seen in the past. The form of this one is y minus y1 is equal to m parenthesis x minus x1. So if you are given one point and a slope and you are asked to write an equation, a lot of people like using this method instead. And it easily transfers into y equals mx plus b, which most people prefer to graph lines from. So they work really nicely with each other, and part of your homework is going to have you pair them together as well. So let's take a look at a couple of these. So if we were going to use point-slope form, y minus y is equal to slope times the quantity x minus x1. Okay, so this becomes y plus 7 is equal to 2x minus 6, and then move your 7 over. So in slope-intercept form, we end up with y equals 2x minus 13, and we're ready to graph. Okay, let's take a look at another one. If we have a slope of 0 and a point 1, 1, y minus y1 equals to the slope x minus x1. Now notice that y minus 1, if we take 0 times any quantity, we're going to get 0. So ultimately, we end up with y is equal to 1. Okay, another horizontal line. Which, given a slope of 0, we could actually have figured that out from the beginning, couldn't we? Parallel lines and perpendicular lines are also two concepts that we're going to review with this section. Remember that if lines are going to be parallel, they must have identical slopes. That's what keeps them from running into and intersecting each other. Perpendicular lines are lines that have negative reciprocals as slopes. So for example, if one line had a slope of 2, a perpendicular line to it would have to have a slope of negative 1 over 2. Okay, so let's take a look at that. If we're given the point negative 4, 1, and an equation 5x minus 3y is equal to 8, let's find an equation of a line parallel to it passing through the given point. All right, so first of all, we need to know what slope we're dealing with in that given equation. If we want to be parallel to it, we need to know what slope would get us parallel to it. So rearrange your equation so that you can see your slope. So the slope of that given line is 5/3. So I know I'm going to use 5/3 again for a parallel line. And we're looking at that point, negative 4, 1, that was given to us for this problem. So if we use our point-slope form, y minus y1 is equal to the slope times the quantity x minus x1, which would turn to x plus 4. Okay, so start simplifying. We have 5/3 x plus 20 over 3. Add 1 to both sides, and we get y is equal to 5/3 x plus 23 thirds. Okay, give you a couple seconds to look at that one. Same thing is going to go for the perpendicular line, except now instead of an identical slope, we want its negative reciprocal, which would be negative 3 over 5. And we again are still considering that same given point. Load it back into your point slope form. And simplify. Add 1 to both sides. Y is equal to negative 3/5 x minus, let's see, would be adding 5/5, so minus 7/5. Looks about right. Okay? Now, using slope as a ratio, turn to page, let's see, turn to page 166. In example 6 there, it talks about a ratio that's needed for a wheelchair ramp not being able to exceed or be steeper than 1/12 or 1 to 12, as in if it would raise or rise 1 foot, it could go horizontally for 12. All right. So if we're looking at whether or not a particular ramp that was built is good or not good in respect to that ratio, what we need to do first of all is set up that ratio. So if we have the problem that's given us in the book, we have 22 inches of rise and 24 feet of length. Well, notice that those two units do not match. So first thing you're going to need to do is convert those feet to inches. 12 times 24 is 288. So we have our 22 inches that it can rise, and then the run is 288. Well, hopefully you remember how to turn this ratio into a decimal. If we were to go ahead and divide 22 by 288, we would get approximately 0.076. Now, to compare that, we need to look at the given ratio of 1/12. If we take 1/12 and find that ratio, it's just about 0.083. The 3 is repeating, but we round it off to 0.083. That ratio has a smaller value than the 1/12, so that particular wheelchair ramp would have been just fine. Now, using slope as a rate of change, if you drop down the page, it says in this particular one there, I'm using the checkpoint one this time. So there's one done for you in the book as well. You can look through, but I'm going to do the checkpoint one at the bottom of the page. It talks about an accounting firm determining that the value V in dollars of a copier T years after it's purchased is V is equal to negative 300T plus 1500. Describe the practical significance of the y-intercept and slope of this line. All right, so if you look at this particular thing, do you notice that it's in a y equals mx plus b format? Which would mean this is your y-intercept. Okay, so if t was 0, the value of the copier would be $1,500. Why does that make sense? Well, if the time or the year was year 0, you just got it. So it should still be worth the purchase value of $1,500. So that makes perfect sense. Now, what does the negative 300t indicate? Well, that slope of negative 300 means that it's going to go down $300 for every year. Okay? So, for example, if the machine was 1 year old, what would you expect it to then be worth? Okay, well, you'd have to take negative 300 times 1 times that 1 year and then reduce or simplify. You'd have negative 300 plus 1,500 or $1,200 now. Okay, so how many years would it take in order for this machine to have absolutely no resale value left or trade-in value left? Well, if that year ended up getting to 5, okay, the value of that computer or that copier is back down to 0. Okay, so at 5 years old, it's probably an indicator of how long they figure that copier is going to last for you. Okay, beyond 5 years, it's not going to be worth anything in trade-in. Probably means it's about time to replace. Now, using slope to show depreciation kind of is similar to that rate of change, but look at the straight line depreciation on the next page. Okay, so again, there's one in the book, but we're again going to focus on the checkpoint problem at the bottom of page 167. A manufacturing firm purchased a machine worth $24,750. The machine has a useful life of 6 years. After 6 years, the machine will have to be discarded and replaced. That is, it will have no salvage value. Write a linear equation that describes the book value of the machine each year. All right, so a couple of facts that we know from this. Brand new, that machine was worth $24,750. So at year 0, it was worth that much money. Okay? Now, it's telling us that there's going to be 6 years worth of quality life. So the time of this machine's worth is somewhere between 0 to 6 years. Let's see. Does it tell us what this is going to depreciate each year? Oh, sure it does. Because at the end of 6 years, we don't have any value left. All right, so if we were going to use our data points, we know we're only talking about this short period of time. Okay, it's going to go from $24,750 down to 0. So my rise over my run. Okay, so I get 24,750 on top over -6 here. And if I reduce that, let's see what I get, -4125. So that tells us how much money it's going to lose every year. So if we were going to write a linear equation, our value, we'll just use V. You could use Y and X if you still want to, but your value is going to be this much loss per year plus, we'd want that to be our y-intercept, right? So that was, we get that from our point 0, 24,750. Because again, at time of 0, that machine was still worth all of its value, $24,750. So here'd be our linear equation. Last one, I think. So the sales for Nokia were approximately $58.6 billion in 2009, $56.6 billion in 2010. Predict the sales in 2013. All right, well, if we're looking at 2009, we could use 9 as our X value and 58.6 billion as our Y. 2010 would go with 10 for our X value and 56.6 for our Y. So figuring out our slope, again, whether you pick one of those for your X1, X or Y1, X1, Y1, or your X2, Y2, it doesn't matter. I'm going to go with the top one being Y2 and my bottom one being Y1, and I have to stick with that same order for the X's. So I end up with 2 over -1 or a -2. Okay, so if I'm going to predict this for the year 2013, okay, I want to know what's going to happen when my X value is 13. Oh, I need to finish out my linear equation. Sorry, I only got halfway there. All right, so once we have our slope let's take one of our 2 points, use those in our point slope formula so that we can come up with an actual equation. They didn't give us an equation on this one. All right, so I think I'm just going to use the first one. So y is equal to mx plus b. So 58.6 is equal to negative 18 plus b. Add 18 to both sides. And I'm looking at 76.6 is equal to b. Okay, so now my linear equation is as given. Now I can use my year 13 to make a prediction for what y is going to end up being. And it looks like Nokia is going to be worth roughly 50.6 billion at that time. All right, so there was one more application problem, but I chose not to go through that one because frankly I have a feeling most of you are tuning out at this point anyway. So for your assignment for today, again, I'm going to kind of stick as I have been in leaving the amount of problems that you need to do up to you. I understand or realize that a good share of this stuff, that the y equals mx plus b and maybe the point slope and things like that, are things that you do remember from the past. But I urge you to do a couple from each section still, and then spend a good share of time in the application problems that are towards the end. Technically, there are 114 questions in this section. I do not at all expect you to even do half, but please be thoughtful when you choose problems out of here. Being there is so much review in this section, I'd really like for you guys to do well with section 1 on this chapter. All right, so give the video a look. The assignment starts on page 169. And again, I'm just going to give you guys the freedom I forgot to type this before, I guess. So really focus on the word problems here with this section. I know they're your favorite. Whoops, I can't talk and type at the same time. Okay, that's all I got for you. We'll see you guys in class.